Welcome to Rojo Builds. We're back in the garage, and as you saw the week, just a few days ago from this recording, we were out at the track. We made some passes. We made 5 passes. We got the car to go a little bit quicker. We got the car to go 10th quicker. This is by freeing up the brakes, and I'm still working on the tune-up. We are still working on the tune-up. But I ran into probably just mostly one problem, major problem, was the two-step at the track. I tested it multiple times in here in the garage. It worked fine, but so far, every single time I take it to the track, something happens with the two-step. So obviously, I cannot trust that bots anymore. But so after the first time it happened to me, I was like, for my birthday, I'm gonna get myself a little gift. So, before I take the car out again, I'm gonna be switching over to this. Hold on. So I got the new MSD 6AL bots that is fully is digital and completely programmable, and it has a built-in 3-step, and it has a bunch of parameters from launch retard. So in case you're bad track prep or whatnot, it has launch retard. You can retard going down the track, so you could actually ET a little bit better. You could start retard is built in. It has 3 steps. It's fully. I mean, I should really review this in a separate video, which I might do. It has a lot more control. So the 7AL bots in there's nothing wrong with the 7AL bots. The 3-step is what's wrong. But if you try to buy a brand new 3-step bots, it's like I think almost $200, and then you got pills. All the pills now are almost $50 each for a pack. Or if not, I think over $50 each now for a pack. So it gets pretty expensive, especially if you have 3 different sets. For high RPM limit, that's over $50 there. For launch RPM limit, that's another $50 there. And then the chips comes in odds and evens on top of that. So if you want to, you get a set of even chips or a set of odd number chips. That's over $100 for, let's say, a set in the 4,000 range. So with this bots, I can set it to whatever I want, and you could also control it with your phone. So like I could be in the middle of the pits, and if I want to see the guy launched in front of me and they spun the tire, I could pull some timing out at the launch, and it's kind of pretty impressive that the technology has leaped forward. This bot's I think it was in the $460 range from Summit. So it's not the cheapest bots in the world. It's not the secondhand. It's not secondhand or anything. It's brand new. But I think it's something that I treated myself with in the car, and I think it will actually help greatly. Just getting my 60 footers down, if you saw, it is pretty much our biggest struggle right now. 150 60 footers is for a 1040 car is pretty slow. It should be almost up to like a 10th quicker than that. So it made it even quicker than that with converter change and stuff like that. There's other changes I'm going to be doing for safety. So I'm going to try go 9s with the way the engine is. The format from before from carb to pan internally. You know, the cam, the heads that are on it, and whatnot. The thing that I will have to change is to a bigger push rod, and I'll show you why right now. This is what we have for Valvetrain. The girdle with comp golds, but if you notice, there's two things that should be kind of worrisome for an engine that's gonna, that's been spinning pretty close to, or if not right up to 8,000 RPMs. We have two things going on here. A steel retainer, which is not the best thing to have for this type of application, and also 5/16 push rods. So even though I'm pretty confident when I put this more together, I use thicker 5/16 push rods. They're not 80,000 watt. They're I think like 105 watt, I believe. I don't have to put the phone down to probably take this out, but it's most likely a little bit on the thin side. When it comes to push rods, the overall diameter is more important than the actual thickness. And I at the time was less informed than I am currently, and I tried to get the lightest push rods I could put in there at the same time and still be stiff, when it's probably most important to have, the thickest push rods to help keep control of the valve train. Do I think I'm going to valve float? I'm not 100% sure. I don't think so. But this is like a safety precaution, because as the mile an hour goes up, the car is only going to RPM a little bit higher. And I'm already going beyond what this cam was designed to do as well. This cam was built to, it was a 263 at 50. Is again a cam that I got secondhand on the intake load. So this thing is already moving past its peak through the traps. So a cam change will make my life so much easier with this combination. It really would. I could change the cam, and I think it would get me right to where I need to go. That being said, I think if I keep tuning on this combination, I think it will also get me there, and it also teach myself and anyone that's watching, to refining your combination pretty much. I still think there's more refinement left on the table. I have a bunch of more ideas to get the car to go a little bit quicker, but first is these push rods. So let me take this girdle off, and then we'll show you what we have here. So we encountered our first little problem here. On this cylinder head design, the push rods are on the intake side, especially. They're completely, like, the heads are encapsulate the push rod. So let's say, like, on the exhaust side is not that big of a problem, because it's like open into the head. On the intake side, that is a problem. I can actually show you on a set of heads I have here, and explain the little problem that we're gonna have, and I don't have to think of a way to fix it. And maybe you guys could help. All right, this is a standard non-ported head of the same head that's on the car right now. These are the Sportsman 2 heads. So on the exhaust side, you could easily just grind and make whatever space you need for the push rod hole. On the intake side, it's solid all the way through and follows into the port. Now I ported these heads, and I'm not sure how much room I could have. I can't just bore a hole and be sure that I'm not gonna cut into the intake port. So we have a little bit of a dilemma per se. I could just put the stiffer push rods onto the bigger push rods onto the exhaust side, being that the exhaust side is actually opening on the pressure, and that's the side that's gonna be most to have deflection. But the intake side is still, I have a stiffer push rod on it. It's a thicker diameter 5/16 push rod, but it still leaves a little bit to be desired. Putting the titanium retainers will be an improvement, weight wise, and easier for the motor to control it. But I really have a lot to think about. If you guys can post some ideas, and on the comments below, and as I sit and ponder myself on how I go about doing this. I do plan on doing these heads up in the future. And if I do them, I will prepare them for the application. But I will actually do something a little different, and I will save that for that day. I have an idea for these heads, and I actually got it off, believe it or not, those good old Ford boys, and what they do with Ford heads. I want to actually try something on this head. But anyway, we're jumping too far ahead here. We got to worry about the problem that's in front of us, and right now, putting the right size push rod in here. So, man, I don't know what to do. So, help me out here. So I was recording that last piece. I started talking a little slower, but I'm thinking as I'm talking, and I came to realization that this is the push rod I thought was in it. They were on my rack. This is the push rod that was in it. This was in the motor. This is an 80 thousandths wall push rod, and I was spending this motor $8,000, close to $8,000, 7,900. It was right there. I was pushing my luck for sure, and most likely I was starting to get into the beginnings of valve float for sure. This push rod was definitely doing the bendy straw. So what I'm gonna do, I know this motor was able to rev for the most part with the 5/16 push rod, that's 80 thousandths wall. I'm gonna try to find some 120 wall 5/16 push rods, and try running it like that this year, because with the 3/8 push rod, the exhaust side, like I showed before, I'll be fine. On the intake side, it's gonna be a problem, and I really want to continue racing this year, and there's gonna be more preventative maintenance. I also found some titanium retainers I had put away. I should have actually another set of these, and I'm pretty sure these are all in good condition. I'm gonna check them all, and then if there's any that are a little suspect, I'll switch them out with some other ones that I have. So, switching to a titanium retainer, putting a stiffer push rod in it, and honestly, this motor might have a little bit more top end now. It didn't feel like it was floating, but it could possibly be. But this is why we test and stuff like that. So we're gonna change the push rods. I'm gonna change the retainers, and we're gonna change nothing other than that, and other than the MSD bots. We will put the MSD bots in here, see if that will improve the launch. But between the MSD bots, nothing's gonna change on the motor. If we gain mile an hour, then most likely this motor was floating at the top end. We're running into some type of valve float. So, with that being said, I think this video is gonna be kind of a mess, but thank you anyway. Like, share, subscribe, ring the bell, and I think we're gonna do something cool soon.